Hey kids, welcome to section 7.6, solving rational equations. Today we're going to learn how to solve rational equations. So all of these equations are going to be fraction looking because rational means fraction. Equations that contain one or more rational expressions are called rational equations. There's easy ways and hard ways to solve rational equations, kids. The easiest way is to eliminate the fractions by multiplying each side by the least common denominator, or the LCD. So what you're essentially doing is you have these equations that have fractions and all sorts of things going on in them, and you're going to try to look at the bottoms of the fractions, the denominators, and try to find the least common denominator if you were, say, going to just be adding or subtracting these like we did earlier in the chapter. So for instance, if we're trying to solve letter A, we take a look, we have 2 over x plus 3 over 2 equals 19 over 10. The easy way, the best way to do this, is to take a look at all the denominators. So x plus 3, 2, and 10. And what we're going to do is we're going to try to figure out what we could multiply the entire thing by, and that entire thing is called the least common denominator. So first of all, I need a number that my 2 and my 10 can go into evenly. Well, that's 10. Then I need to include anything with a variable, so I've got x plus 3. So essentially now I have an x plus 3 in my LCD. I have a 2 in my LCD because it's buried in the 10, and my 10 is in my LCD. So now I'm going to take each of my fractional portions of my equation and I'm going to multiply it by this LCD. I'm going to write the first one out with lots of writing, and you probably aren't ever going to want to do this, but it'll help visualize. So I'm going to take the first fraction, 2 over x plus 3, and I'm going to multiply it by the LCD, which is 10x plus 3. Then I'm going to take the middle fraction, 3 over 2, and I'm going to multiply by 10 times x plus 3. I'm going to put it over 1 just so I can have a top and a bottom to look at. Then I'm going to take the last fraction, 19 tenths, and I'm going to multiply it by 10 times x plus 3 over 1. Okay, so why I did this is because it allows you to visualize what happens when you distribute. So when I multiply 2 over x plus 3 times 10 times x plus 3, my x plus 3 simplify, and I have a 2 and a 10 left over, plus. Then when I multiply my middle two terms together, or my middle two fractions, I should say, the 10 can go into, or the 2 can go into the 10 5 times, and so I have a 3 times 5 with an x plus 3 left over. When I distribute on the right-hand side, my 10s simplify away, and I have a 19 and an x plus 3. So what I essentially did is I kind of wrote out what we were going to be able to simplify so that you could actually visualize each term being multiplied. A lot of you might be able to start down here where you're in your head just kind of simplifying it away. Your choice. All right, now we just get to solve. So 2 times 10 is 20, plus 3 times 5 times x is 15x, and 3 times 5 times 3 is 45, equals 9 times x is 19x, and 19 times 3 is 57. Okay, on the left side, collect like terms. 15x plus 65 equals 19x plus 57. Move the 19x to the left by subtracting. Negative 4x plus 65 equals 57. Then I'm going to subtract 65 to both sides. So that's negative 4x equals negative 8. Divide both sides by negative 4, and you get x equals 2. One thing you want to do is you want to make sure that whatever value you get works in the problem. Now, the only way the answer is not going to work is if it's one of the excluded values from the very beginning. In the very beginning of the chapter, we talked about excluded values. These were values that make the denominator 0. So this part right here, x plus 3, means that x can't equal negative 3. Well, we got 2, so we're good. If we had done all this solving and got x equals -3, we would have said, oh, son of a nutcracker, and we would have said, oh, we can't have that, no solution. So always be thinking about those excluded values or the values that would make the denominator equal to 0. All right, let's look at letter B. 5 over y minus 2 plus 2 equals 17 over 6. First thing I'm going to do is put a 1 underneath the 2 because I like to visualize the top and the bottom to the fractions. Now I got to figure out what I need to multiply the entire thing by to get rid of all the fractions. Well, number-wise, I got a 1 and a 6, so that means I have 6. And then I have a y minus 2 with a variable, so y minus 2. Now we're going to take each of the parts of the equation and distribute out the lowest common denominator. So let's see, when I multiply the 5 over y minus 2, the y minus 2's are going to go away, and I have left 5 times 6. In the middle, I have a 2. Well, nothing is canceling, so I have a times 6 and a times y minus 2. On the right-hand side, I have a 17. When I multiply, the 6's simplify to 1, and I get y minus 2. All right, so 5 times 6 is 30, plus 2 times 6 is y. 2 times 6 times y is 12y. 2 times 6 times -2 is -24, equals 17 times y, 17y. 17 times -2 is -34. On the left side, we can collect like terms. 12y plus 6 equals 17y minus 34. I can subtract 17y to both sides. -5y plus 6 equals -34. Subtract 6 from both sides. -5y equals -40. Divide by -5, and we get y equals 8. Remember, check those excluded values. My excluded value comes from right here. Y cannot be 2, so I'm good with 8. All right, let's see what we got on the next page. Ooh, okay, these kick up a little bit. So if you look at letter C, now notice that I have a quadratic in the denominator on the right-hand side of the equal sign. Before you look for any common denominators so you can find the lowest, make sure you factor anything that can factor in the denominators. So my z plus 1 is fine, my z minus 1 is fine, but z squared minus 1 can factor into z minus 1, z plus 1. Now we can figure out what our lowest common denominator is. Well, it looks like I need a z plus 1 and I need a z minus 1. All right, so now we're ready to distribute. In my first fraction, when I multiply by the LCD, my z plus 1's go away. So I have a 2 and a z minus 1 left. And I'm going to write my 2's a little bit curlier because the 2's and the z's look the same. All right, then I have the minus 1 there. My z minus 1's cancel, and I have a z plus 1 left over. Equals, I have a -2, and when I multiply, everything cancels in the denominator with the numerator, so I just have -2. All right, so now let's distribute. So we've got 2z minus 2 minus z minus 1 equals -2. Collect like terms, that gives me z minus 3 equals -2. Add 3 to both sides, z equals 1. All right, let's check for excluded values. Uh-oh, excluded values. Z can't be plus or minus 1. And we got +1. So therefore, sorry bud, no solution. All that work just to get no solution. So always check to see if the answer that you got will not blow up the denominator, because that would be bad. All right, letter D. Remember, before you do anything, factor those denominators so you can see what you're working with. The first fraction, I can take out a 3. Oop, not m, that's an n. Take out a 3, so we have 3 times n plus 1. The middle one we can take out a 4, so we have 4 times the quantity n minus 1. And the right fraction I could take out a 2, so 2 times the quantity n plus 1. Okay, so it looks like we're working with n plus 1s and n minus 1s. We also have to figure out what number. So we have a 3, a 4, and a 2. So you want to find the least common multiple of 3, 4, and 2. That's 12. I can use actually any multiple of 12 if I wanted to. I can use 24 or 48 or even 120. As long as it's a multiple for all the numbers, then it works. It just means that your numbers in the problem are going to be larger, but you will still get the same answer. Okay, so now let's multiply. So I've got that 7 there. When I multiply, the n plus 1s go away. And the 3 goes into the 12 4 times, so I have a 4. And I need an n minus 1. So again, I saw that 3 went into 12 4 times. That's where the 4 came from, and an n minus 1. Then I have a minus 5 in the problem. When I multiply, the 4 goes into the 12 3 times, so I have a 3. The n minus 1s cancel, and I need an n plus 1. Equals, I have a 3 there. The 2 can go into the 12 6 times. The n plus 1s go away, but I need an n minus 1. All right, so that gives us 7 times 4 times n is 28n. 7 times 4 times negative 1 is minus 28. Negative 5 times 3 times n is negative 15n. Negative 5 times 3 times 1 is negative 15. Equals 3 times 6 times n is 18n. 3 times 6 times negative 1 is negative 18. All right, collect like terms. 28n minus 15n is 13n. Minus 28 minus 15 is negative 43. Equals 18n minus 18. I can subtract 18n, subtract 18n. Negative 5n minus 43 equals negative 18. I can add 43 and add 43. Negative 5n equals 25. Divide by negative 5. N equals negative 5. Make sure that you check your excluded values. It looks like n cannot be plus or minus 1. So negative 5 is okay. All right, let's see what we got here. All right, always look at those denominators. Oops, sorry guys. Always look at those denominators to try to figure out what's going on. If I look in the first one, my middle denominator can factor into p plus 4, p minus 2. That makes it really nice because notice the other denominators are p plus 4 and p minus 2. So when I find and multiply, my common denominator that I'm going to multiply by is p plus 4 times p minus 2. So when I multiply my first fraction by the LCD, the p minus 2s are going to go away, and I have 1 times p plus 4. Don't really need the 1 there, but it's kind of habit. Then I have the p plus 4s go away, the p minus 2s go away, and I have 2p plus 1. Plus, I got the 2. The p plus 4s are going to cancel, and I'll have a p minus 2 left over. So now let's distribute. We get p plus 4 equals 2p plus 1 plus 2p minus 4. So left side is p plus 4 equals 4p minus 3. That's minus 4p minus 4p. Negative 3p plus 4 equals negative 3. Okay, minus 4 to both sides. Negative 3p equals negative 7. Divide by negative 3. P equals 7/3. Sometimes you get a fraction and think you did it wrong. Sometimes you get a fraction and it's totally right. This time it's totally right. But check your excluded values. What can P not equal? P can't equal negative 4 and a positive 2. Well, fortunately for us, 7/3 is not those two numbers, so we are good. It's a 7. All right, B. Well, no quadratics, so nothing to factor, no GCFs. Okay, so we got to figure out our LCD. Well, I need a 4 and a 12. Well, I can use 12. And then I need the y plus 3. Common denominator, 12 times the quantity y plus 3. All right, so multiply the first fraction. We have an 11. The 4 goes into the 12 3 times. And I need the y plus 3. Minus 5. The y plus 3's cancel, and I need that 12. So times 12 equals, I have a 23. The 12s will simplify, and we got y plus 3. So that's 11 times 3 times y, that's 33y. 11 times 3 times 3, that's 99. Minus 5 times 12 is 60, equals 23 times y is 23y, and 23 times 3 is 69. Collect like terms on the left. 33y plus 39 equals 23y plus 69, minus 23y to both sides. 10y plus 39 equals 69, minus 39 minus 39. 10y equals 30. Divide both sides by 10. Y equals 3. Check for excluded values. Ooh, y can't be negative 3. So y equals 3 is a valid answer. All right, what's next? Okay, so in letter C, it looks like we have a quadratic that we can factor. It's the difference of two squares, x minus 2 and x plus 2. And fancy enough, that's what the other two denominators are. So our lowest common denominator is x minus 2x plus 2. So if I multiply my first fraction, I have a 5. My x plus 2's will go away, and I need an x minus 2. Minus 3. My x minus 2's will go away. I need an x plus 2. Equals 12, and my x minus 2's and my x plus 2's go away. So I've got 5x minus 10 minus 3x minus 6 equals 12. Collect your like terms. 5x minus 3x is 2x. Negative 10 minus 6 is negative 16 equals 12. Add 16. 2x equals 28. Divide by 2. X equals 14. Check your excluded values. Looks like x can't be plus or minus 2. So 14 is good. Okay, if we look at letter D, I'm going to put a 1 underneath. I'm not seeing any factoring. I need to find my lowest common denominator. Between a 1 and a 3, I need a 3, and then I need the 2x plus 1. So when I multiply, I've got the 10. My 2x plus 1's will cancel, and I need a 3. Plus 4. My 3's are going to cancel, and I need a 2x plus 1 equals 2. And I need the 3, and I need the 2x plus 1. So that gives me 30 plus 8x plus 4 equals 2 times 3 times 2x is 12x. 2 times 3 times 1 is plus 12. Collect like terms on the left side. 8x plus 34 equals 12x plus 12. Minus 12x minus 12x. Negative 4x plus 34 equals 12. Subtract 34, subtract 34. Negative 4x equals negative 22. Divide by negative 4, x equals 11 halves. It's a nice fraction. You can say 5.5. You could say 5 and 1/2, or you can leave it 11 over 2. Check for excluded values. In this case, the only excluded value that I can't have is if I set this equal to 0, negative 1/2. It's the only excluded value I cannot have. Wait, hold on. This isn't 22. Yeah, it is. For some reason, I'm thinking 28. Never mind. Okay. Wait a second. Yeah, that's right. I don't know why I'm doubting myself. Weird. Okay, word problems. So the way we're going to do these word problems is this is two different versions of the same type of word problem. These problems are all about people working together to do a job quicker. So it takes Bill 9 hours to mop a warehouse. Don't ask me what kind of warehouse he's mopping or why he's mopping it for 9 hours, but he's mopping it for 9 hours. Sarah can mop the same warehouse in 11 hours. How long would it take if they work together? Round to the nearest hundredths. Okay, so if Bill and Sarah work together, then they can say something like this. Bill plus Sarah. So the time it takes Bill plus the time it takes Sarah would be the time it takes them to work together. Now, Bill doing it in 9 hours is completely different scale than Sarah doing it in 11 hours. We can't really compare them. So what we're going to do is compare how much they get done of the job in 1 hour. So we can compare how much Bill gets done in 1 hour to how much Sarah gets done in 1 hour, and then we can use that to compare together. So if it takes Bill 9 hours, then in 1 hour, he will have completed 1/9 of the work. So this is in 1 hour. Then Sarah, if it takes her 11 hours, then in 1 hour, she will have done 1/11 of the work. Now, if I add those together, that's supposed to tell me how long it takes them to work together. Well, if it takes them X hours to work together, then in 1 hour, they will have completed 1/X of the job. So this is essentially what the work equations look like when you talk about people doing jobs with different rates and then working together. Now this is an equation that we can find a lowest common denominator for. Multiply the 9 and 11 and the x, the LCD is 99x. So when I multiply the first equation, 9 goes into 99 11 times, so 11x plus 1/11 times 99 is 9x equals, and when I multiply 1 over x with 99x, the x's cancel and I get 99. Collect your like terms, and I get 20x equals 99. I can divide by 20, and rounding to the nearest hundredths, 4.95 hours. I really think they should work together because it's taking them 9 and 11 hours separately. Crazy. Okay, Sally and Melanie were able to wash a boat in 7 hours together. So we've got Sally plus Melanie equals together. So they can wash the boat together in 7 hours, so in 1/7. If Melanie takes 10 hours to complete the same job alone, so 1/10, without help, how long will it take Sally to complete the same job? So Sally is 1 over x this time. So notice this time the variable is on the left side of the equation, whereas before it was on the right side of the equation. It doesn't matter as long as it's on the proper side for the problem you're doing. Here we can multiply by the LCD, which is going to be 7 times 10 is 70 with an x. Then I'm going to distribute 1 over x times 70x is 70. 1 over 10 times 70x is 7x, equals 1 over 7 times 70x is 10x, minus 7x minus 7x. 70 equals 3x. Divide by 3. Divide by 3. It says to round to the nearest hundredths. This gives us 23.33 hours. So I think Sally needs to really get some help because 23 hours washing a boat is a long time. All right, kids, that's the end of section 7.6. If you guys have any questions, please let me know. And as always, keep calm and keep trucking.